This is question 3 from paper 2-3 from the June 2020 exams from Cambridge International. Up the top right of the screen, you'll find a card that will bring you to a playlist of all my other solutions from this paper. And in the description below, you'll find a link to an image of this question, and I recommend you try the question before looking at my solution. In this question, they give us this equation here to a curve, or many curves in fact, as we're going to see in a moment, and they ask us to find the gradient of the curve at this point here. Now, we don't have access to graphing software in an exam, but as you're watching this video right now, I'm guessing you're not in an exam, so I do recommend when studying to look at some of this graphing software. Have a look what this equation looks like. I'll pop that up on the screen right now. As you can see, there's many curves satisfy this equation, and you'll also see I've put a point on the screen where that is the point they've given us. So that is the gradient we're looking for. Now, like I said, that graph is not necessary to do this question, but it's interesting to see, I think you'll find. Okay, so we hear gradient, we should be thinking differentiation, dy dx. But that's not going to help us too much in this question. We're used to the idea of y equals, let's say, 2x. And we differentiate, we get dy dx, and we get 2 over here. But I'd just like to point out what we're doing here. We're actually doing d dx on y. We're doing something to this y, d dx, to get dy dx. And we're doing the same thing to the 2x on the other side. And again, this just turns into 2. So with that in mind, we can actually do that on this equation here. Even though there's no y equals, there's a y all the way in here. And hopefully doing this d dx on the whole thing will find us a dy dx somewhere. And then after a while, we will get dy dx equals something at the end of this. So let's give that a go. Let's do, well, let me write it out like this. D dx of cosine 3x plus d dx of 5 sine y is equal to d dx of 3. So we've been fair to everything here. We've differentiated absolutely, well, we're going to. We've just put in the symbol for it now. So it's sort of like multiplying. Once we multiply everything, we're being equal, we're being fair. So let's do this. We differentiate cosine. The derivative of cosine is sine on whatever's in here. Sorry, it's minus sine, is it? Yes, it is. Minus sine. But there's a 3x in here, so we have to use the chain rule. What I've just done is the derivative of cosine something, but that something had an x. So we need to respect that, and we need to differentiate what's in here. So that is 3x, the derivative of 3x is 3. So let's put that out front, multiple by 3. Okay, the next one is, sorry, not an equals here, a plus. Well, I'll leave it, we'll see what appears. So the derivative of sine y. Now there's no x in here, but we can still differentiate it. We just pretend it's an x, just like we did here. We pretended that it was a simple x. So we can differentiate just the same. 5 doesn't matter. And then the sine, the derivative of sine is cosine. Cosine, whatever's in here, we just leave it alone. But we cheated again. We pretended this was just a simple x. It's not. So we need to respect it. We need to differentiate it. So let's multiply it by its derivative, and that's dy dx. So that's where this dy dx appears from. And that equals the derivative of 3. How much does 3 move when x moves? Nothing. So that's equal to 0. And now we just need to rearrange it. So we have dy dx. So let's do that. Dy dx, I'll do it quickly. I think we are all ready for this. We move this across the equals, and it becomes plus 3 sine 3x. And that will still be here. So we need to divide that across the equals. That becomes divided by 5 cosine y. That should be an s. Apologies. And that's everything we need. We've got dy dx. Some students might be worried about this y here, but don't, because remember, they told us what y is. They told us what x is, they told us what y is. So if we want to find the gradient, we simply put these numbers into this equation. So let's do that over here. Dy dx is equal to 3 times sine 3 times pi over 9. Instead of x, I'm putting pi over 9. And that's divided by 5 cosine pi over 6. Now, a calculator will do this for you, but you don't need it because we already know what some of these are. Well, first of all, 3 and 9 cancel. We get pi over 3. So 3 times sine pi over 3, we can look that up. I have to look it up myself. And we get square root of 3 over 2. That'll be in your tables. And divide that by 5 multiplied by cosine of pi over 6 is again square root of 3 over 2. They cancel. And we're just left with 3 over 5. A calculator would have given you that on this part if you want to use it. But sometimes that can be dangerous because sometimes the exam asks for exact answers. In this case, it cancelled, so it's fine. But it can be dangerous. I recommend doing it out the way I've just done there. All right, I think that's the full marks. Let's have a look. Find the gradient of the curve at that point. And yes, we could go back to that picture. Let me throw it back up onto the screen. And I can't see it right now, so hopefully we all agree that the gradient is about 3 over 5 at that point. It's positive, it's going up, it's not quite 45 degrees, it's a little less than that. All right, if you have any further questions though, please put them in the comments below and I'll do my best to answer. Thanks for watching and have a great day.